In algebra, each time we use letters of alphabets, we employ them to depict an unknown number of items in a bundle. If you see Y, for instance, Y means unknown number of items in a bundle. So Y is a bundle containing an unknown number of items. Is it only when we know number of items that we can add, subtract, multiply, and divide with them? Is it possible that though we don't know a number, that we can tell the result when we carry out addition, subtraction, multiplication, and division with that number? That takes us to the third lesson objective of this lesson, and that is arithmetic of bundles. In this section, I seek to explain how to carry out arithmetic operations with number even unknown. Let us now turn our attention to objective number 3, and that is arithmetic of algebraic bundles. What do I seek to achieve in this section? I intend to use pictures to explain the differences in the way people count items around them. People can count just anything. Let me use counting peanuts as an example. We have 3 sets of drawings here: the first, the second, and the third. The first drawing depicts dots scattered in the way I've seen them. Each dot was drawn to represent a peanut. And as you can see, there is no boundary. Don't have boundaries that demarcate one set of peanuts from the other. What it means is that they are free. There is no boundary. Please, when somebody wants to know how many peanuts that there are in this arrangement, what would the person do? The person has no option but to count them one by one. Counting the peanuts, one peanut after another peanut, is an example of what I call counting in units. It is also possible to take some peanuts here, a specified number of peanuts, and pack them inside a container. It could be a can, it could be a bottle, it could be anything. But that bottle or container of any kind contains a specified number of these peanuts. Somebody could take 100 peanuts and put them in the container, and the container is filled up. Somebody can pick 500 peanuts and put inside a container, and the container is filled up, depending on the size of the container. Let each of these squares represent a can into which some of the peanuts have been placed. So if I pack peanuts into this, into this, into this, and into all the 8 cans, and each can is filled up, and now you want to count the peanuts, are you still going to be counting the peanuts one by one? Note that a specified number filled up this can, a number filled up this can, a number filled up this can. Either the same number or different numbers, but each can has a specific volume and number of peanuts it can accommodate. If you are to count how many peanuts across these 8 cans, will you still insist on counting the peanuts one by one? No. You would now realize that since we now have boundaries, you count them by how many cans. So if you are told to state the quantity of the peanuts, you will say you have 8 cans of peanuts. Now, at this point, you are counting the peanuts in bundles, no longer in units, no longer one by one. That's the second method of counting things. Still, it is possible to join 2 of these cans and put into a carton. Another 2 you put into a carton. Another 2 you put into a carton. Another 2 you put into a carton. At last, you have 4 cartons, each of 2 cans. A carton of a can is no longer a bundle. It is now a bundle of bundles. Note how we started. First, counting one by one. Next, putting a number into a can and saving it. Next, putting 2 or more cans into a carton. Therefore, this depicts counting in units, while this line depicts counting in bundles, and this depicts counting in bundles of bundles. Let me write these methods. And here they are. This, that is number 1, corresponds to counting in units. This, that's number 2, corresponds to counting in bundles. While this, that is number 3, corresponds to counting in bundle of bundle. Now, let us assume that the same number of peanuts is inside each of these cans. Since this can is of an unknown volume, it means that it can accommodate an unknown number of peanuts. Let me assume I don't know how many peanuts that this can accommodate. But if this accommodates 100 peanuts, the rest also accommodate 100 peanuts. Let's simply assume that they all contain 100 peanuts. What if they contain more than 100 peanuts, like 120 and even 200? The fact that they can contain different numbers of peanuts, because we don't know how many they can contain exactly, we simply say that the number of peanuts that this can accommodate is a variable number. Because we don't know it, we're going to choose a letter of alphabet to represent it. I want to use Y to represent the unknown number of peanuts that each can accommodate. Let me write Y in each can. And here they are. Y, 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 up to 8 cans. It means that the same number of peanuts that are contained here are also contained here. If the number of peanuts here is not the same thing as this one, there is no point writing Y and Y here. The fact that you have Y everywhere shows that the same number of peanuts is contained in all of them. If I have written Y, C, Z, M, that would have meant that all these corresponding cans contain different numbers of peanuts. But as you can see, all the 8 boxes contain the same number of peanuts. That is why they all bear the same alphabet, Y. That does not mean that Y is the only one we can make use of. I just chose Y. You could as well choose any other alphabet to be that which Y is doing for us here. Okay, then if you pack 2 cans into a carton, what will you call each carton? That is from here, this boundary, right, that makes a carton. What are you going to call that carton? Since here is Y and here is Y, that is this Y from this can and Y from this can, what then will you call one carton? Will you still call it Y? No, it is not going to be Y because it is 2 Y's that make up this one. Therefore, this carton is Y into 2, that is Y plus Y, and that will give us 2Y. So let me write 2Y corresponding to each of these cartons of peanuts. And here they come. 2Y is name of this carton. 2Y is name of this carton. This one also is 2Y. Not just a name, but what tells us how many peanuts we're going to get. What we don't know is what Y is. But once we know what Y is, we can use this thing to tell how many of them, which means the formula for knowing how many peanuts in this carton is 2Y. Y represents the unknown, the number of peanuts which we don't know here and here. If this y is 100, certainly a carton will be 2 times 100. That will give us 2 times 100 is 200 peanuts. With that, we can avoid counting one by one. If this one too contains 100, 100, that is if y is 100, another y is this 100, then 2y means 2 times y, and that will be 2 times 100. That will also give you 200 peanuts. That means that we count faster by multiplying 2 by the number of peanuts in each pack. The same thing happens to this and this. So please, which one is easier? Is it counting in units, counting in bundles, or counting in bundle of bundles? The easiest is this, followed by this, but the most laborious is this first set. So anytime you want to make counting quite easy for yourself, adopt the third option, counting in bundle of bundle. So far, while counting this, we will count one by one, taking our time, taking our energy. But after you put the peanuts into the cans, we can now categorically say that there are 8 cans of peanuts. And we can say that there are how many cartons of peanuts? Remember that this is a carton. So we have 4 cartons of peanuts and 8 cans of peanuts. Under arithmetic of algebraic bundles, we seek to learn how to get and count in bundles and in bundle of bundles, since counting in units is an age-long process that we know, especially in basic arithmetic. It is these two we are concerned with: counting in bundles and counting in bundle of bundles. Arithmetic involves 4 basic mathematical operations. We call that they include addition, subtraction, multiplication, and division. Take for instance, if I decide to put 1, 2, 3, 4 together in one carton, and I want to know how many peanuts are in that carton, do you think that each carton will still be 2y? The answer is no. It is going to be equal to 4y. How do I get that? I will simply say y plus y plus y plus y, and that will give us 4y. That process is arithmetic. That process of adding y to y to y to y is arithmetic process. Again, if you come here and you say 2y, because you want to know how many peanuts in an entire carton, what you don't know is what this y represents. Like I said earlier, if y represents 100 peanuts in one pack, it means that with this formula you can tell how many peanuts in a carton. That is going to be 2 times 100. Is that not multiplication? It is. Multiplication is also an aspect of arithmetic. But because you are multiplying with unknown, that is, y here is unknown, and you are multiplying the unknown with some other things, we simply refer to it as arithmetic of algebra. That means you are multiplying an algebraic term. We can also talk about division and talk about subtraction. After all, there are many ways people intend to combine things. On a daily basis, we see cases of addition in real life, cases of subtraction in real life, cases of multiplication in real life, cases that take us to different and even more complicated mathematical operations. In this section, we wish to learn how to add, subtract, multiply, and divide algebraic bundles. We're going to start with this one. Later, we'll talk about arithmetic of algebraic bundle of bundles. Please permit me to concentrate on this. That is where the coefficient of the unknown is 1. Here it has 2 as its coefficient. So bundles are known by the fact that they have 1 as their coefficients. From now on, I will be talking about how to add, how to subtract, multiply, and divide algebraic bundles. Now, let y be that bundle. And let's learn the results of addition, subtraction, multiplication, and division with y involving the following. The number 1, that is 1. The number 0, then the number itself, that is self, and then other numbers. I believe you have a preview of what I intend to do here. What I intend to do is that I want to carry out arithmetic operations with y. Don't forget that y is a bundle. Later, we'll talk about bundle of bundles. At this point in time, each time we say y or any other alphabet, we can at least tell the origin that that is a bundle. And I want to tell you, or I wish to remind you, if you don't know, that it is not compulsory that y is a bundle that is always above 1. It is possible to have one thing put into a can or put into a container and sealed, which means as long as it is sealed and demarcated, it is still called a bundle. So one item can become a bundle. So do not always think that a bundle must be more than 1. The least you can get in a bundle is 1 thing. All right, so I want to carry out the 4 basic mathematical operations with this y. I want to carry out addition with y. I want to carry out subtraction with y. I want to carry out multiplication with y. I also want to carry out division with y. What do I want to add to it? What do I want to multiply with it? What do I want to divide with it? And what am I subtracting from y? Anyway, I intend to know the result if I add 1 to this y, if I subtract 1 from this y, if I multiply this 1 by this y, and if I divide this y by 1. Later, we'll learn results of what happens if I add 0 to y, subtract 0 from y, multiply 0 by y, and divide y by 0, and divide 0 by y. Later, we'll learn what happens when y is added to itself, when y subtracts from itself, when y multiplies itself, and when y divides itself. Then ultimately, we learn what happens when other numbers apart from these 3 are added, subtracted, multiplied, and divided in connection with this y. I want to start with the first one. What happens when 1 is used to carry out arithmetic operations with y? Please let us see.